So we'll be diving into remote code execution with serialization vulnerabilities. I really should have titled this talk Deserialization Vulnerabilities because that's when the vulnerability is triggered. So a little bit about me. I'm a partner technologist at AVEVA, which means I don't code anymore. My compiler is Visio and Word, but I am involved in application security and overseeing threat modeling, qualifying architectural designs. I've had a few articles published on CISA, Hacker Noon, C# Corner. I did a stint as a startup founder in 2018, and then COVID hit. So now I'm working full time. So a little about remote execution. I had a surprisingly difficult time getting an authoritative definition of exactly what a remote code execution vulnerability is. I think we all have a good understanding of what it is, but does OWASP? I went to OWASP.org and didn't find a definition there specifically. What I did find was two categorizations, code injection and command injection. Either you're injecting code that gets executed on the host, or you're running a command on the operating system. I think this is just splitting hairs, so why not do both? Which is what we will be doing. So a little about the demo I'll show. First, I have a Ubuntu machine. I will open a port I'll be monitoring, port 2222, on my attacking host, and it will be waiting for an inbound connection from my Windows host. When that connection is established, I'll have a command shell on the Ubuntu host that will give me the same level of access as the web server running on the Windows host. So picture, if you will, for a moment, a REST API deployed in your corporate environment, and you've got a deserialization vulnerability. You're exposing yourself to a remote command and control from somebody that just needs to send in an HTTP request. It could be JSON, XML, binary serializer. It doesn't matter. So a little bit about serialization. It's taking an object model and representing it in an inert state, whether it be XML, JSON, or binary serialization. Where this becomes a problem is when the message defines the type to deserialize as. That's when you have the vulnerability. I'll say that again, because this is an important point. The message is vulnerable if the message defines the type to deserialize as. That gives the attacker the option to override what is in that message initially and provide a vulnerable type. I'm used to C#. I worked at Microsoft for 12 years. I'm a .NET person. But this exists in Java. It exists in Python. It exists in any languages that deal with serialization, deserialization. It doesn't matter. The same principles I'll show you here apply irrespective of the language and irrespective of the serialization format. So if the type is vulnerable, you are vulnerable. So what types are vulnerable? Ones that expose gadget chains. And we've got a few conditions for vulnerability. It's not just that the type has to be present. It's having a type in your app domain, in your process, that can be subverted, exposes you to this vulnerability. So like .NET framework is full of these. How many of us have legacy applications running around in our environment still? Right? We don't want them, but they're out there. So if you've got .NET 4.8, older versions of Java, you probably have some gadget chains lying around on your web servers. So a gadget chain allows the attacker to define a code that they can execute. So How many times have we written an API and the business has come back and said, oh, we need to capture some additional data. We don't know what the data looks like. The customer can send whatever they want. And you end up with a hash table or generic, like a dictionary string object, right? And you may have like a metadata property on your object that allows for this hash table. That's a gadget. That object is exposure. So there's some classes in .NET Framework, like claims principal.
Just looking for my other mic like that. There should be another one. There it is. Thank you.
Claims principal, role principal. There are easily a couple dozen of these that make this gadget weaponized. So let's expand on that UML model for a moment. We got the Ubuntu attacker, we got the Windows target, but in the middle is that REST client, waiting for that inbound message, waiting to be exploited. So on the Ubuntu machine, I'll open my listening port. On my Windows target, I'll send a malicious payload from my REST client to my web server host, and that will open a reverse shell back into my Ubuntu attacker, and I'll have command and control. And that's impetus for least privilege, right? Because once I open that shell, I'm running under the identity of the process of that host. So any good cybersecurity practice will have you implement least privilege. So at least if somebody does exploit your Windows host, there's your web host, they have a limited blast radius. You're only constrained by the rights of that web server. All right, so with that, that's about as much PowerPoint as you're going to see. All right, so on to a demo. So I've got my VM running. And I'll use NCAT.
Should we be seeing that?
That's a little bit of a spoiler. All right, so.
We're not seeing.
One moment. Okay. All right. So can everybody see that, the command line? Coming in well enough?
Make it a little bigger.
I can take the lights off. I can take the lights off and make that.
Sure. Well, Zoom isn't cooperating too much. All right, there we are. All right, so I've opened up a port on my Ubuntu machine, VNLP, verbose, no domain resolution, listen on port 2222. All right, so my machine's in position, and now I'll go into our code. But first, let's drill into what precisely will be happening here. So this is a malicious payload. This malicious string, which looks like nonsense, it's just a base 64 formatted string that is using the binary formatter. Microsoft has come out and said that the binary formatter is going to be removed in .NET 9. This vulnerability has been known for some time. It was introduced in .NET Framework. Microsoft tried to remove it in .NET Core 1.0, and well, a lot of stuff broke. They reintroduced it, but now they're really serious about getting it out of .NET 9. So, you know, even though your dev team may have the binary formatter in use, getting them to remove it or getting agreement in your organization to remove it could be a challenge. So you may need to prove that it is indeed vulnerable in order to get that traction. When you walk out of here, I'm hoping that you have the knowledge to make that happen in your own organization. So this string itself looks awfully innocuous, but what it does do is take the claims principal and it will execute calc inside the constructor of the binary of the of this message. So it is impossible to create a malicious binary format or JSON formatted message programmatically in .NET or in Java or in most other languages. You need some intermediary to perform some surgery on that serialized package. And that was done by this ysoserial command. So there's a Git repo, ysoserial, that elaborates on Java vulnerabilities and Java serialization vulnerabilities specifically, and ysoserial.net. This was generated, this string was generated ysoserial.net, which manipulated a claims principal class that was serialized using .NET, just using the binary formatter, and it was fine. You could deserialize it, no issue. But run it through this ysoserial string, and you inject a command, calc.exe. All right, let's run this. Okay, an error occurs, but we have calc. So who cares about the error? We just exploited the machine, right? We just launched calc from the constructor of claims principal on deserialization. There are no CVE vulnerabilities for this, by the way. You won't get any, Dependabot telling you to upgrade because of this vulnerability. So switch back to our REST API and go ahead and launch. Oh, I have another instance running. Just a moment. All right. So I've got my Ubuntu machine ready to receive. This how to create a simple to-do REST API off of Microsoft Learn site. So this just keeps a very, so where am I? Still not launching. See, this is the risk with live demos. Yeah, this. All right, it's staying. So I'll go ahead and run a innocuous message. It's just a GET request to retrieve a list of to-do items. I'll send a request, get a to-do item back. It's behaving as expected until we get to this launch calc. All right, I'll send. There's our calculator, launched through the API. If we were running, if this was off a web server in your corporate environment, it will have launched on that web server. So now I'll go ahead and launch NCAT. So from the client machine, what I have is a payload, again, generated with ysoserial. using binary formatter and the claims principal. This time, I'm running ncat rather than calc. And I don't know if you can see that well enough there. I'll zoom in. There we go. So there's the command line that will be run. ncat, and that will open up a command line reverse shell back into my Ubuntu machine. Send a request. There's the client launching. There's the command shell. Now, what do you think we'll see over here? Ta-da! I now have access to my host machine command line. I can, under the IIS Express account, right? Using just a binary format message to make it happen. I pass that in a JSON payload. That JSON payload overrode the normal deserialization process you would get off that metadata package and deserialized it as a binary format message, and there we are. But that's not all. We can also do this with JSON. And most of us probably aren't sending binary serialized messages over REST APIs, right? But we are sending JSON. And I've got a JSON vulnerability that surfaces, unfortunately by default, Newton's. How many people here, by the way, that are using .NET are also using Newtonsoft in their environments? Anybody? All right, well, if you are using .NET Framework, chances are pretty good that you're using Newtonsoft. This particular vulnerability will surface if the type name resolver, here by the way, is set to anything other than none. That's how it comes in. What will happen is you'll get a payload that gets serialized as a with some additional metadata. You get this type definition, and herein is lies the problem. You know, now once again you've got a message that's defining the type to deserialize as, and we've got system claim identities, which under the hood is still using binary formatter. Newtonsoft doesn't have to be told to use the binary formatter; it implicitly uses it. And once again, you have the same vulnerability, except this time it's JSON. So I'll go ahead and run it, and I'll set up one more time on my Ubuntu machine. All right. I'll stop the, that guy should be stopped. It's right formatter. Looks like IIS is not cooperating with me. But suffice it to say, what you would see is another reverse shell established using JSON. This occurs with message pack. This does not occur with system text JSON. So if you have upgraded from .NET Framework over to .NET, or you're on modern on a more modern stack, you're less likely to get hit by this, but it's not entirely impossible. So this is one example of a gadget chain that's built into the .NET framework, but you can also inject your own gadget chain. So in .NET, if you're using, you're no longer on the .NET framework, those same gadget chains that, claims principle is still there, but the implementation is no longer vulnerable under .NET 8, .NET 9, etc. But what you can do is add your own gadget chain. So what I've done in this example is placed a DLL called someimage.net or someimage.png. Imagine having a website where you're uploading an image file. But you've taken a DLL, renamed it to the image file, uploaded it. You can do a load assembly on it. You can bring it into memory and then execute that same command line operation. And so I know we only have a couple minutes left. Let's see if I can get this one in. So I've got a DLL here that is very simple. This DLL, just when I call the setter on process launch, it calls process start on the value of the property. So the serialized message that I'll be sending will just apply calc.exe to that process launch property. And here we are. And it is not responding to me. Oh, I need to do the load assembly first. There's that file that I would have uploaded by some other means that's waiting to be loaded into memory. That's my gadget chain. If you don't have your own gadget chain, you can make one. Right? I just did. I placed one onto the host, and then I make use of it to launch calc. So even if you don't have a gadget chain, there's another vector you can get at. Now, this is also available on my Git repo. So everything you've seen is documented. The code samples are available on this Git repo, and the process is documented as well. So didn't have to take any notes. Any questions? Yes. I'm sorry.
How can you detect it in
How-
a Windows environment?
How can you detect if you have this vulnerability in a Windows environment?
After it's executed, can you detect it after it executes? Someone does it in the environment?
So after the fact, can you tell if somebody has exploited it on your server? Gosh, that's what I would have to rely on Siemens SourceTools for. You could detect it using WAF to some extent. WAF may be able to detect some of malicious payloads coming in. You could use RASP to detect if there are any processes that are running that you don't expect to be running on the machine. So there are ways to detect it, but honestly, prevention is the best approach. And doing a search to see if you're using the binary formatter in the first place is a good first step. Looking to see if you have, if you're using Newtonsoft and you're using that type name resolver is another good approach. And take a look at these why-so-serial Git repos. There are numerous white papers at the end of those repos that go into much more detail. Yes?
Does this only work if you're deserializing into like a generalized object?
Yes, that's right. If it's a type that does not expose an object or doesn't expose, like if it has a property that's another type that that exposes an object, you could still have a problem. So if you have like deeply nested object relationships, you would need to inspect every one of those. Yeah, yeah, child class and child and child. Yeah, generics could also be susceptible. Yeah, yeah. Any others? All right. Well, thank you.